Hello and welcome to helpyourmath.com. In this video, we're going to look at simplifying expressions containing rational exponents by using properties of exponents to simplify each of the following as much as humanly possible. So remember the properties of exponents, we have same base multiplication. So that would be like x to the a times x to the b. We could rewrite this as x to the a plus b, right? We can add the exponents. Or we could have same base division, which would be x over a divided by x over b. And then here we would subtract the exponents. We could also have power to a power, that would be x to the a to the power of b, in which case we would multiply the exponents, that would be x to the a times b. So we want to keep these properties in mind, although what we're looking at is going to be a little bit scarier than what we're used to, but we're going to get through it and it's going to be great and you're going to do great. Okay, our first example, what is this? Take a deep breath. I know we see fractions and that's scary, but it's okay. We can do this. This is same base multiplication. How do we deal with same base multiplication? We can add the exponents. This would become x to the 3 over 7 plus 2 over 7. Now these fractions conveniently already have a common denominator, so we can just add across the top and that would be 5 over 7. So we end up with x to the 5/7, and that's it. That's all we can do. Okay, what do we have here? This one is power to a power. And what do we do with power to a power? We multiply the powers. So this is going to be 5 over 4 times negative 12 over 5. The 5s will cancel. We end up with 1 and 3 here. So this ends up becoming negative 3 over 1, which would just be b to the negative 3. We probably don't want to leave our answer with a negative exponent, so we can rewrite this as 1 over b cubed. And this would be our final answer. See, that's not so bad. That was kind of nice, right? How about this one? This is same base division. What do we do with same base division? We subtract the exponents. So this would become p to the 5 over 6 minus 1 over 2. If we're going to subtract with fractions, we do need a common denominator. The common denominator between 6 and 2 would be 6. So we're going to rewrite 1/2 with a denominator of 6, which would be 3 over 6. So this becomes 5 over p to the 5 over 6 minus 3 over 6. Now we can subtract. 5 minus 3 is 2 over 6. We can simplify this to p to the 1/3. So this would simplify p to the 5 over 6 divided by p to the 1/2 simplifies to p to the 1/3. What we could do, so there's two different ways of looking at this. I kind of like dealing with this thing first, this negative exponent that's getting distributed to every factor, every base we see, means take the reciprocal of what's inside the parentheses. And to do that, we're going to put everything under 1. So this becomes 1 over negative 216 a to the 9th. Notice the negative here stays, right? The reciprocal of a negative is a negative. So we need to make sure we include that negative. What we have dealt with is we've dealt with that negative 1/3. Now it's just 1/3. All right, so now we want to distribute that 1/3. 1 to the 1/3 is going to be 1, so I'm kind of going to ignore that. This would be negative 216 to the 1/3. And then we have a to the 9th to the 1/3. Well, let's start here with the negative 216 to the 1/3. This would be the cubed root of negative 216. And the cubed root of negative 216 is negative 6. So this becomes 1 over negative 6. Okay, how about this here? We have a to the 9th to the 1/3. That would be a to the 9 over 1 times 1 over 3, right? That's power to a power. So we multiply the exponents, and then we would end up with a to the 3rd. That a to the 3rd was in the denominator, so it stays in the denominator. So we have 1 over negative 6 to a to the 3rd, or we could put the negative in front. If you want to put it here, that's fine. If you want to leave it in the denominator, that's fine, but you can't do both. You can't have it here and here. That would actually be a positive, which would be wrong. So I'm just going to leave it down there because I can, and this would be our final answer. All right, in our last example, we're looking at everything. First thing I want to do is get rid of the parentheses, and in order to do that, I need to distribute that power of 8. So we're going to focus on the numerator because that's the only place where we're distributing the 8. This would be m to the negative 1/2. This is power to a power, so we're going to multiply by 8. And then times n to the negative 3 over 1 times, oops, I don't need to put 3 over 1, do I? Because there's no fractions here. So it would be negative 3 times 8. Okay, so here Oh, look. Oh, that's nice. We end up with m to the negative fourth times n to the negative 24th. Okay, that was our numerator. Now, let's put this over our denominator because there's no simplifying needed in the denominator. 3 over 2. What we might want to do is, what I like to do is I don't like dealing with negative exponents. So anywhere I see a negative exponent, I'm switching its location. In fact, the only place I see the negative exponents are the numerators. So both factors of the numerator are moving down to the denominator, giving us what was already there, m squared n to the 3 over 2. Joining them is m to the 4th and n to the 24th. Now we're not done yet because we should only have one of each base. I see I have m squared and m to the 4th. So this becomes 1 over m to the, what do we do when it's same base multiplication? We add the exponents. That would give me a total of 6 factors of m in the denominator. What about the n's? So the n's, again, I want to add these, but this one's a little bit tricky because I have 3 over 2 plus 24 over 1. I need a common denominator. The common denominator would be 2. So I'm going to multiply this fraction by 2 over 2. This would give me 3 plus 48 over our common denominator of 2. And we end up very awkwardly with 51 over 2. So this would be 1 over m to the 6th times n to the 51 over 2. And we're just going to leave our answer like that. We're not going to worry about anything weird that might be happening there. These have been examples of using the properties of exponents on rational expressions, on rational exponents. Thank you for stopping.